Oh, that's weird. I feel like the first slide is already wrong. Okay, that's odd. Okay, well, we're missing the first slide on my slide deck. First of all, I want to say thanks to Nicholas for that presentation I was watching from the back, and it's amazing where RSD has come, because it's been a while since we started that effort, and Nicholas has been such a driving force behind that. So thanks again. Okay, yeah, this is the default slide that comes in the React Conf template. I don't know why that all of a sudden appeared, but basically before it had my talk name, which was Reimagining Lists in React Native, and my name is Luna Wei, as was already mentioned. Oh, and I'm missing my presenter notes. Okay, well, it was basically like, thanks everyone for being here today. I appreciate you guys all coming here, and I know it's like the last talk before lunch. So I'll try to keep it brief. And yes, my name is Luna, I mentioned that. And I've been working on the in the React org for about 7 years now. I've been working on things like product support, performance, convergence, or what Nicholas was kind of talking about, and releases. And so last year, I went on mat leave, had a baby, and yeah, it's been fun talking to everyone about what parenthood looks like now. So I came back and I joined this effort on the React Native team to revisit our core APIs because, as I already spoiled this slide, and also as Ricardo mentioned in the keynote, new architecture is the architecture today. So at Meta, I think within the last year, we've migrated the long tail, I should be using this clicker. We've migrated the long tail of React Native apps to the new architecture, which has been a big effort, so shout out to that crew. And then last year, as we shared, we enabled new architecture by default for React Native releases. So again, just reiterating the fact that new architecture is the architecture. Okay, gotta get on the pauses. Now that we've gotten here, what are we doing with the new architecture? So it helps to remember what was the purpose of new architecture. It was about unlocking capabilities and improvements that were impossible in the old architecture. And a limitation I want to focus on today is lists, and specifically blanking lists. I don't know if you guys are familiar, but this is what I mean by blanking. I actually tried to get a video of a blanking list, so this is actually a keynote animation, but it essentially looks something like this. And if you're like a seasoned React Native developer, you've probably seen a list that's blanked. But yeah, basically you're scrolling a list, and your content occasionally disappears. And it isn't a great experience, especially for mobile apps. Because lists are critical to mobile UI. Most mobile apps are essentially infinite lists. And because they're so highly interactive, users are super sensitive to jank or dropped frames. So developers use a strategy called virtualization to deliver performant large lists. So virtualization is the strategy to render only what's visible to the user and update items as the user scrolls. This gives us the illusion that the entire list is rendered without the performance cost. Now, I mentioned virtualization because that's only one part of the reason why we get blanking in React Native. The other part is the architecture. So let's take a closer look. In a mobile app, you have the main or UI thread to draw views and handle user interaction. There's a fixed frame rate to repaint the UI, similar to web, to keep a smooth experience. And that's what we're representing there with those green bars at the top. That's a frame drawn under deadline. So React Native does its rendering work on a background thread. And when it completes, it communicates the changes to the UI thread to paint. So for the example of a list, what are we seeing here? Oh yeah, the scroll event fires from the main thread. And then say the scroll event is the user scrolling to 200 pixels down from the top. The list is virtualized, so nothing is rendered right now at position 200. The scroll event gets passed to React on the background thread, it renders, and React starts rendering items at position 200. But before React finishes, the main thread paints the current frame, but React hasn't finished rendering. So the main thread paints the frame without the items actually rendered at position 200. And this is why we get blanking. And the problem gets worse if a user scrolls really quickly. A background thread can get overwhelmed with a lot of rendering work, while the main thread remains oblivious and continues to paint frames. So when the user does stop scrolling, they have to wait until React finishes the backlog of render work for stale scroll positions before it can actually render the visible items at that last scroll event. So that's what I'm representing here with the red tasks or render work on the background thread. That's stale render work. However, this problem isn't unique to React Native. Modern web browsers also use a separate thread for scrolling to manage, they composite layout and dispatch scroll events, and while your JS is running on the main thread in a web browser. So let's say if the main thread is busy, which it is right now, as you can see, if we have a scroll event, that scroll event handler might take a while, may take a couple frames to actually get called. But why aren't people talking about blanking on web as much? Or I haven't heard it, at least. That's because users have different expectations of UI depending on the platform. And as mentioned, mobile users expect responsive, smooth lists. So what do React Native developers do today to mitigate scrolling or blanking? Well, they use strategies like pre-rendering, which is rendering items around the viewport in advance to reduce the risk of a user scrolling to empty content. However, it will always be possible for a user, to scroll fast enough that you'll still get blanking. So it's not actually solving the real problem. What we really want is for, what we really want is for the main thread to wait for React to finish rendering before painting the new frame. Or put another way, React Native renders asynchronous to the main thread by default, so how can we start rendering synchronously? So to help understand that, I took it back to first principles because I think it's always fun just to go back to first principles. So React describes UI from some state. So in the context of React Native, we will take that UI description and pass it to the mobile platform to draw. When the state updates, React does the work to update its description of the UI and commit it to be painted by the platform. That's what we mean by render work. But how do you get a state update? Well, most commonly with events. Events drive updates to the UI. And in the case of React Native, events originate from React Native. They could be user interactions from the platform or a custom React Native event. So the event gets dispatched to React to trigger the render work. Okay, so now we have the event and the related render task. But how do we actually get from dispatching the event to running the render task? Well, the React Native event loop, and we've kind of talked about it a couple of times today. Or should I actually say the React Native runtime? As an aside, just to clarify what I mean by a runtime, essentially, it's everything you need to run React apps. That includes events, the JS engine, the APIs provided by the host environment, and UI, which is the renderer. And on the browser, or on the web, you get this from the browser. And in React Native, we have to provide a lot of these APIs. And similarly, you saw, or notably you saw that we added DOM APIs and performance in there. But most relevant to this talk, we want to take a closer look at the event loop. Because React Native manages the event loop for React. So in a React event loop, or in an event loop generally, there's a task queue. And so when an event gets dispatched to React, when React Native dispatches the event to React, a relevant render task is scheduled in the task queue. React Native then selects that task from the queue based on priority and deadline and runs the task with Hermes, our JS engine. And all of this is happening on the background thread. And since React Native controls the scheduling and execution of JS work, we can define certain events that, when dispatched, signify we need to run the next event loop iteration on the main thread. This is what we call synchronous events. So this was unclear to me for a while, but like synchronous events trigger synchronous rendering. So what does that look like for our problem of list blanking? How do we solve it with synchronous events? So a sync scroll event is fired on the main thread. It tries to access the JS engine. Once it has the JS engine, the main thread can run the render work. Once it completes, it can paint and release the JS engine back to the background thread to continue rendering on the background thread. Yay, we've done it, okay. We've rendered on the main thread, guys. Woo! But, of course, is this actually a good thing? So the first problem I want to highlight is when, let's say a sync event comes in, I mentioned that we have to wait for the JS engine to run the render work because JS engines are single-threaded, like you can't run multi-threaded JavaScript. So we have to wait for it to be available, but let's say that there's some long-running task on the background thread that's holding on to the engine. And when we finally do get the access to the JS engine, it may take so long that the frame drops. We could fix this problem by using more concurrent features, concurrent APIs, ideally to break up that long-running JS work on the background thread. This way we could schedule yieldable work such that we could get the JS engine earlier to ideally, hopefully not drop the frame. But using concurrent APIs is not a direct solution to the problem, just more of a preventative strategy. Another problem we encounter when we start to render on the main thread is that events are batched. So we're not really just getting like one sync event and handling it in a render task. We batch a lot of events together. So that means that the render task that's running on the main thread may capture more work than just handling that sync scroll event, again, causing a potential frame drop. Oh, okay, so clearly, rendering on the main thread comes with trade-offs, but it does guarantee correctness, and rendering on the background thread is still best for performance, but it could also be rendering stale data. So can we find a way to use the right strategy at the right time? What if we only rendered on the main thread when absolutely necessary, like when the content in a list is unrendered but about to become visible, and leverage the concept of pre-rendering to reduce work, or to reduce the risk of needing to render on the main thread, and doing that on the background thread. So if we imagined for a list item component in a virtualized list, we'd ideally have a scroll event handler that could render synchronously if the item isn't rendered and about to be in the viewport, and asynchronously for pre-renders or for when it's actually going to be virtualized. And I wanted to add a note here. This feels like we should be using activity, but activity particularly manages priority in React Scheduler, versus right now we're talking about different threads in React Native. But we'll get back to activity later. And that's what we're exploring with VirtualView. Sorry to kind of cut it short there, but yeah, so VirtualView is an experimental component we're releasing in 82, and it virtualizes its children based on where it's rendered in relation to the viewport. So instead of listening to a scroll event, it listens to a mode change event, because every virtual view has a mode. VirtualView defines 3 mode regions in relation to the viewport: hidden, pre-render, visible, and visible being the actual viewport. A virtual view's mode is determined by which region it's rendered in. So when a virtual view's position changes into a new mode region, that's when we fire a mode change event. And depending on the mode change, we determine whether the event is synchronous or asynchronous, and what priority we render updates in. So in the case of hidden to pre-render, it's an async event, as the item is still far away from the viewport. And we render those updates in a transition, as it's non-critical UI work that can be interrupted. For pre-render to visible, any guesses on what we do? That's it. We do nothing. We don't emit event because the content has already been pre-rendered, so we don't really need to do anything at that point. So the interesting case is when we go from hidden to visible. This is when we know we need to prioritize rendering the content right now. So we emit a sync event. And we render at the default priority in React, which is just the non-interruptible React update. So that's VirtualView, the new component in React Native. Applause, potentially. Thank you. VirtualView gives the power of virtualization, and it sets the right priority and thread to render, pre-render, or hide its children. It fixes the root issue that causes blanking by leveraging the main thread when needed. But if we're reimagining lists in React Native, VirtualView isn't a list, but rather a building block that can be leveraged in a list implementation. And so for the past year, we've been iterating on virtual column and virtual row, not pictured, and we refer to these as virtual collections. Virtual collections are list primitives that focus on lazy mounting, layout, virtualization of its items through VirtualView. So when we were designing this API for virtual collections, we took inspiration from other mobile UI frameworks. And we saw the power of decoupling the scroll view from the list implementation to allow a minimal API surface and extreme composability. Just for a note, scroll view is a component that enables scrolling for a view. So it's like the overflow scroll in a component form. So now, for virtual row and virtual column, you'll need to explicitly wrap your list primitive in a scroll view. And without a scroll view as part of the list, it's simple to arrange and nest any combination of virtual collection, such as rendering multiple columns, nesting a row, and all with virtualization that just works. Yeah. Virtual collections also lazily mount just the necessary list cells while preserving the priority of each mode region. As an example, say for initial render or after a scroll, we first identify if there's any gaps in the visible region. Then we render the items to fill that region on the main thread. Then, after the main thread after the visible viewport has been filled, we identify any empty space in the pre-render region and render additional items to fill that gap on the background thread. Other things we've been exploring in virtual collections is learnings from the community, React Native lists in the community. We saw the importance of optimized parameters by default to avoid performance pitfalls. So this is an area we're continuing to explore, but we hope to dive deeper into dynamic pre-render regions based on scroll behavior, such that the pre-render region scales based on whether you're scrolling faster or slower. So yeah, that's virtual column and virtual row. So should you be using virtual column today? Virtual column is not a flat list replacement yet. It's a reimagining of a list primitive in React Native that just focuses on the layout, lazy mounting, and virtualization. And lists are complex. Flat list does a lot because we need our lists to do a lot. So that means to use virtual column, we have to offload a lot of that complexity to other places. And we don't really have the answers to that yet. So it's very primitive and basic in what it's trying to achieve. So in the end, all I'm saying is these components are experimental. And while we have been testing these components in production, to be successful requires other experimental APIs, or maybe not so experimental since we did just announce DOM APIs, but like other things like intersection observer that are yet to come. And we also hope to leverage more optimizations in the future to make this even better. So things are changing. But that being said, VirtualView is in the 82 release, and we do have docs out. So if you're working on lists or virtualization, we welcome you to try it out and share any feedback with us. We hope to release virtual column and virtual row documentation, and also the components, in the 83 release. But because these docs are experimental, just a note, you have to search for the actual component name in the latest version of the docs. Okay, so to close it all out, we talked about a lot of things. First of all, React Native manages a lot, since it manages essentially a runtime, which is a lot of things that is just handled by the browser for web. But being a runtime gives us a lot of control and flexibility. With these new components, we can synchronously render on the main thread for the first time, as mobile UI frameworks do, but not be constrained to the main thread like mobile UI frameworks are. And in addition, we can continue to render on the background thread by default to prevent frame drops and maintain responsiveness. So we got ourselves a pretty sweet deal. Yeah. And lastly to note, synchronous events and these new components have been built on a decade of innovation in our frameworks. I'm probably wrong in the ordering of this, and actually a couple of these APIs we don't explicitly use, but this is a rough timeline of some of the capabilities that this work relies on to be able to do main thread rendering. All the way back to like 2016, when we started breaking up rendering work into chunks, to obviously all the new architecture work to allow synchronous access to the runtime from native platforms, to Hermes and Hermes GC to allow us to have more performant JS work on the thread to like not block the main thread for too long. But that's all to say, I think Rick even shared this note with me a couple days ago. Back in 2017, we've been talking about synchronous rendering and lists for React Native. So it's been a long time coming. And I'm so glad that we've gotten to share this with all of you today. Yeah. And so my last slide is a thank you to the team and to everyone who's helped me with this presentation. It was a lot of back and forth, and I'm actively working on the next generation of lists. If you see us around, feel free to come and chat more about lists. So thank you.